how to monitor AI agents after launch. Passing your test suite is not the finish line. It is the starting line. An AI agent can pass every golden task today, then fail next week because the data changed, the tool changed, the policy changed, or the workflow changed. That is why production agents need monitoring, not just uptime monitoring, behavior monitoring. You need to know what the agent saw, what it decided, what tools it used, when it stopped, when a human overrode it, and whether the pattern is getting worse over time. In this video, I'll show you the monitoring layer I would put around an AI agent before trusting it in a real workflow. Normal software monitoring tells you if a service is up, slow, or throwing errors. That still matters, but agents need another layer. You are monitoring a decision loop. The agent receives context, reasons through a task, calls tools, reads outputs, makes recommendations, and sometimes takes action. So the monitoring question is not only did the request succeed, the real question is, did the agent follow the right path? Did it use the right evidence? Did it call the right tools? Did it respect approval boundaries? Did it stop when information was missing? Did the human reviewer agree with it? If you cannot answer those questions after the fact, you do not have production monitoring. You have hope. The first signal is the trace. A trace is the timeline of what happened inside the agent run. At minimum, log the user request, the retrieve context, the tool calls, the tool outputs, the final recommendation, and the reason the agent gave for that recommendation. Do not only save the final answer. The final answer is the least useful artifact. When something goes wrong, you need the path. For a security agent, this means you should be able to inspect which scanner, finding it used, which asset record it checked, which policy rule it applied, and which ticket it created or refused to create. A good trace lets you replay the decision. A bad trace leaves you arguing with a paragraph. The second signal is tool call behavior. Agents often fail through tools before they fail through language. They call the wrong tool. They call the right tool with the wrong parameters. They skip a required lookup. They retry too many times. They use stale context when they should refresh data. So track tool call accuracy as a production metric. For each important workflow, define the expected tool sequence. Then measure when the agent follows it, when it skips a step, when it calls extra tools, and when tools fail. If your vulnerability triage agent recommends priority without checking asset exposure, that should show up immediately, not after someone finds it in a ticket 2 weeks later. The third signal is human review. If your agent has approval gates, those gates are not just safety controls. They are monitoring signals. Track how often humans approve the agent's recommendation. Track how often they edit it. Track how often they reject it completely. Track which fields they change. If reviewers constantly lower the severity, the agent may be over-prioritizing. If reviewers constantly add missing evidence, the agent may be under-citing sources. If reviewers keep changing the assigned team, the routing logic may be wrong. Human overrides are not noise. They are labeled feedback from production. The fourth signal is drift. Agents can drift even when nothing is broken at the infrastructure level. The model may respond differently. The data distribution may change. The workflow may start receiving edge cases. The agent may become more verbose, less cautious, more expensive, or less aligned with policy. You can detect this by tracking output patterns over time. For example, monitor severity distribution, refusal rate, missing data rate, escalation rate, confidence language, and reviewer override rate. If a triage agent used to mark 10% of findings as critical and now it marks 40% as critical, you should investigate. Maybe the environment changed, maybe the agent changed. Either way, you need to know. The fifth signal is operational health. Cost, latency, and retries matter because they often reveal hidden behavior changes. If cost suddenly doubles, maybe the agent is retrieving too much context. If latency spikes, maybe a tool dependency is slow. If retries increase, maybe the agent is struggling with ambiguous inputs or unstable APIs. These metrics are not just finance and performance metrics. They are behavior clues. A production agent that gets slower, more expensive, and more retry heavy is telling you something changed. You want to catch that before users stop trusting it. The sixth signal is boundary behavior. Every production agent should have boundaries it cannot cross, actions that require approval, data it should not access, tools it should not call, requests it should refuse, high risk states where it must stop. These events deserve their own alerting layer. Do not bury them in normal logs. If an agent attempts a restricted tool call, asks for broader permissions, ignores missing evidence, or tries to complete a workflow that requires human approval, that should be visible. Boundary events are where small agent mistakes become real operational risk. Let's make this concrete. Imagine a vulnerability triage agent running in assisted mode. It reads scanner findings, checks asset inventory, looks at exploit intelligence, drafts tickets, and recommends priority. The monitoring dashboard should show every run. For each run, you want the finding, the asset lookup, the exploit intel check, the policy rule, the recommended priority, the drafted ticket, and the human review outcome. You also want aggregate signals. How many findings were missing owners? How many recommendations were overridden? How often did the agent skip exploit intelligence? How many tickets were blocked by policy? How much did each triage cost? How long did each run take? This is how you move from trusting the agent's answer to trusting the system around the agent. Here's the practical checklist. For every production AI agent, track traces, tool calls, approvals, overrides, missing data stops, refusals, boundary events, cost, latency, retrend, drift metrics. Then define alerts. Alert when required tools are skipped. Alert when override rates spike. Alert when restricted actions are attempted. Alert when cost or latency jumps. Alert when output patterns drift. And most importantly, review these signals on a schedule. Monitoring is not useful if nobody looks at it. The goal is not to make the dashboard pretty. The goal is to catch agent failure before it becomes workflow failure. The safest production agents are not the ones that never fail. They are the ones that fail visibly. They leave traces. They expose uncertainty. They respect boundaries. They create feedback loops. And they give humans enough evidence to intervene before damage happens. If you are building agents for security or operations, do not stop at testing. Build the monitoring layer too. That is what turns an impressive demo into a system you can actually trust.